So I just wanted to run through one of these delta G problems again using standard um, reduction potentials and half reactions for those. So we're going to take a look at the effect of cytochrome C oxidase on oxidative phosphorylation and calculate the delta G for that. And the question or problem starts by writing a balanced equation for the reduction of gaseous O2 by reduced site C as catalyzed by the site C oxidase enzyme in complex 4 of the electron transport chain. And we're given the two standard reduction reactions and their associated standard reduction potentials for each of these. They're both positive, of course. Well, not of course, but they are positive. And we have to read the problem carefully, and it tells us that we are reducing gaseous O2. So we can rewrite that equation, but at the same time, we're going to have to manipulate the reduction potential reactions so we are canceling the same number of electrons. So for the first one, make sure my pen is working here, we have 4 electrons in the reduction potential for O2. So that means we're going to have to multiply the coefficients of the first reaction by 4 to even out those electrons. And if O2 is being reduced, that means we're going to oxidize the reduced cytochrome C. So we have to flip that first equation and multiply by 4. So I'm going to rewrite that as 4 site C, and this is Fe2 plus, going to 4 site C, Fe3 plus 4 electrons. We also are going to eliminate that what am I trying to say? The half mole of O2 by multiplying this by 2 to get that overall reaction with whole coefficients. So we have 2 O2 plus, let's see, 4 hydrogen ions. Whoops. I miswrote this. That was 2H plus and 2 electrons. Sorry about that. I typed it into the Word document. I was looking at the wrong equation. So we have 4 hydrogen ions plus 4 electrons. And we multiplied that by 2, so we just have 1. So I'm going to erase that. And that is going to give us 2 moles of water. And the delta E's associated with these, are negative 0.258. We flip that, so we have to change the sign of that standard reduction potential. And this one remains the same. And we'll add these together, and our standard E of reduction then for the overall reaction is 0.562 volts. Our electrons cancel, which there are 4 each. So we have 4 site C Fe2 plus O2 plus 4 protons, giving us 4 site C Fe3 plus and 2 waters. Getting little marks down here. So now we can calculate our delta G, since we have the standard overall standard reduction potential for that reaction. And that's going to equal negative N times the Faraday constant times our standard E of reduction for that reaction. And we are transferring 4 moles of electrons times the Faraday constant times our standard reduction potential for the reaction in volts. Moles cancel, volts cancel, and our standard free energy then is a negative 2.17 times 10 to the 5th joules.